Hello, welcome guys. So we are back here, and today we are going to discuss a very simple sum from the chapter of circles of grade 9 NCERT textbook, okay, in maths. Yeah, so we are going to do math today, a little math. So the question is in front of you. It's from exercise 10.5 of NCERT. And question number 2, many students find a difficulty in solving this particular question. Yeah, the solution is also available everywhere online, but then it depends upon whether looking at the solution, do you understand this sum? You need to understand the concept, which is very important. So the question over here that goes is, a chord of a circle is equal to the radius of the circle. Find the angle subtended by the chord at a point on the minor arc and also at a point on the major arc. Now remember, when you read the question the very first time, you may get slightly confused. So it is very important that you break the question in order to get to the answer. The first statement states, a chord of a circle is equal to the radius of a circle. So let's draw a circle first of all. Okay, so I'll say, here goes my circle. So please don't mind, it's freehand circle. Okay, so this is a circle, and the statement says a chord of a circle is equal to the radius of the circle. So let me draw a chord, any chord in this particular circle. You know what's a chord? A chord is a line segment that meets the circumference of the circle at two distinct points. Okay, so that's our chord, and now the statement says that the chord is equal to the radius of the circle. So say the center of the circle is taken as O over here, and I now name this chord as chord AB. So I know that OA is going to be the radius of the circle, and definitely OB is also the radius of the circle. So I know that OA is equal to OB. And my first statement says that a chord of a circle is equal to the radius of the circle. So by construction, I am taking such a chord which is equal to the radius of the circle. So definitely this chord AB is also equal to OA is equal to OB. That gives me my first statement clarity in the figure. Let's see, what does it say? Find the angle subtended by the chord at a point on the minor arc and also at a point on the major arc. So first of all, let us understand where will be the minor arc and where will be the major arc. This is my chord AB. So can you tell me, any guesses, where will be my major arc and minor arc? Yes, definitely. This particular arc that you can see, that is from chord A onwards till over here, this forms my major arc. This is my major arc, and the other side, the arc which is formed, is nothing but my minor arc. So that's my minor arc. So now the question is that find the angle subtended by the chord. Angle subtended by the chord means the angle formed or made by the chord at a point on the minor arc. Where is my minor arc? From here to here. Where is my chord? AB. So the angle subtended by chord AB, I can take any angle. Say I take this angle formed by the chord AB, right? Let me consider this point as point P on the minor arc. So my APB arc is the minor arc, when the angle subtended by the chord at the minor arc is angle APB. And they are saying find the angle subtended by the chord at a point on the minor arc and also at a point on the major arc. So here's my major arc. So let me take any point in my major arc as point Q, and I draw an angle or make an angle which will be subtended by my chord AB. By my chord AB. So can you understand this clarity of the figure? By the question, we read the question the very first time, but then we broke it into parts. So part by part, we arrive at a particular figure, and now we know what do we need to find. Definitely, we need to find the angle subtended by chord AB on the minor arc and the angle subtended by chord AB on the major arc. So what can I write over here? So what do I need to find? I have to find angle APB is how much? and I need to also find angle AQB is how much. So I need to find measure of each of these angles in this particular diagram, in this particular sum. And what is given to me? Definitely what is given to me is I know that OA is equal to OB is equal to AB. This is already given to me. The first statement says the chord of a circle is equal to the radii of the circle, right? So in order to solve this particular sum, we are going to use two very important properties of theorem of circle. Okay, and what are those two properties of theorem of circle? The very first theorem states the angle subtended by an arc at the center of a circle, the angle subtended by an arc at the center of the circle is double the angle subtended by it at any point on the remaining circle. I hope you must have already done this particular theorem earlier to solving this particular exercise. If not, so here's a brief part of it. The angle subtended by an arc at the center of a circle. Now, if I take arc APB, which is the angle subtended by this arc at the center of the circle? Yes, you get it. Angle AOB. So this particular angle is the subtended angle by the arc at the center. This angle will always be double the angle subtended by the same arc at any point on the circle. Now in this case it's AQB. So whatever will be the measurement of this angle AOB, half will be the measurement of the angle AQB. Or in other words, whatever is the measure of angle AQB, double would be the measure of angle AOB. So that's our first theorem property that we are going to use in this question. Nowhere online or in any solution they are going to explain you which two properties you are going to do in this sum or use in this sum. Okay, so you need to understand the very first theorem that we are using is angle subtended by an arc at the center is double the angle subtended by the same arc at any point on the circle. The second property that we are going to do is about cyclic quadrilateral. Now guys, can you tell me what do you mean by cyclic quadrilateral? Please be quick, otherwise girls are very fast in answering. Yeah. What is a cyclic quadrilateral? So any quadrilateral, you know, it's a four-sided figure. So a quadrilateral has four vertices. So when the four vertices of the quadrilateral lie on the circumference of the circle, it's called as a cyclic quadrilateral. In this sum or in this figure, can you point out a cyclic quadrilateral? Tell me. I can see point A on the circumference, point P on the circumference, point B on the circumference, point Q on the circumference. So definitely my quadrilateral APBQ is a cyclic quadrilateral. Now since this is a cyclic quadrilateral, I am going to use the second property or the theorem of cyclic quadrilateral, that the sum of the either pair of opposite angles, the sum of the either pair of opposite angles of a cyclic quadrilateral is supplementary or 180. That means angle Q plus angle P will be 180, and angle A, that's QAP, and angle B, that's QBP, will be 180. These are the two properties that we are going to use in order to solve this particular question. Are we clear till here? Hope I am not that speedy. Okay, so we know the question, we have the figure, we know what is given, we know what to find, we know which properties to use. Now let's crack the sum. It's quite simple. Okay, so here goes our solution to this particular sum. Understand, this is not a proof. This is not a proof. So we are not writing proof. It's a solution. We need to find something, right? So solution. Now step number 1, I'll be writing OA is equal to OB, right? Why? The reason is radii of same circle. So my first step is OA is equal to OB, that's radii of the same circle. And the statement states chord of a circle is equal to the radius of the circle. So in the second statement, I also know that AB is equal to OA is equal to OB. This is given to me as per the question, that the chord AB is same as the radius of the circle. That's given to me. So therefore what can I state? That triangle OAB is an equilateral triangle. Triangle OAB, that is this triangle, is an equilateral triangle. And when I say that it is an equilateral triangle, so definitely the measure of each of these angles will be 60 degree. right? So now I know that this implies measure angle AOB is equal to 60 degree. Now I have AOB as 60 degree. What do I need to find? I need to find AQB. Now see, AOB is the angle subtended by the chord AB at the center of the circle, and AQB is the angle subtended by the same chord at the circumference of the circle. The first property, angle subtended by the R at the center, is double the angle subtended at the circumference. So that states that angle AOB is twice of angle AQB. And what would be the reason? You're going to write down this as a reason, your theorem number 1. Okay, so that's angle subtended by the arc. That's the theorem that you're going to state. Okay, so that's the theorem reason that you're going to write. So angle AOB is twice AQB. Now I know what is AOB. That's 60 degree is equal to twice of angle AQB. So that gives me my angle AQB is equal to 30 degree. I number it as 4. So I got the measurement of angle AQB as 30 degree. This is the angle formed at the major arc. What's the question? Find the angle subtended by the chord at a point on the minor arc and also at a point on the major arc. So we found out the angle formed at the major arc. Now let's consider the minor arc. Now you know APBQ is a cyclic quadrilateral. So now I'll write quadrilateral APBQ is a cyclic quadrilateral. It is a cyclic quadrilateral. So since this is a cyclic quadrilateral, the either pair of opposite side is going to be supplementary. So if this is x, this would be 180 minus x. Now we know the measurement of AQB, that's 30. So what will be my measure angle APB? 180 minus 30. So now I can write that since this is a cyclic quadrilateral, angle AQB plus angle APB is equal to 180 degree. What's the reason? Your property number 2. Sum of either pair of opposite angles of a cyclic quadrilateral is 180. See, the sum is so simple, right? So AQB is 30 plus angle APB is the angle formed by the chord as a minor arc equals to 180, and you get angle angle APB is equal to 180 minus 30, that's 150 degree. So now guys, I have the second measurement as well, that angle APB is 150 degree. That's what clears my sum very clearly. So this was the angle formed by the chord on the major arc, and this is the angle formed by the chord on the minor arc, and there goes my sum number 2 of NCERT, which gives me the complete solution of the question. And you know which two properties or theorems did we use. So your job, after looking at this sum, please go through these two theorems, which is given very well and nicely explained in your NCERT text, or keep watching my videos so that you can understand the theorems and properties much more better and in a quicker way. Thank you very much.